In this video, we're going to discuss polynomial functions and some of the key features of those functions. So the first form that we're going to check is what's called the general form. This is how we're traditionally used to seeing polynomials written. In general, we're used to seeing them most of the time written in this way, like f of x equals, and we have this long function. This is what's called descending order, where the largest exponent comes first. And we like things written this way because we gain a few free key features when they're in this type of form. The first one is the degree. The degree is the largest exponent, assuming we only have one variable. So in this case, we only have the variable x. So the largest power of x is 5. We say the degree is 5. The leading coefficient is the coefficient that goes with that term that has the largest degree, so the leading coefficient here is 11. And the constant term, in this case, is going to be -4. It's the term that doesn't have a variable associated with it. These things are going to tell us some very important things about features of their graphs, so we want to be able to identify these. In this example, we have a polynomial that's written in what's called factored form, which has its benefits as well, but it's where it's written as a product of individual terms. Sometimes we want it in this form, sometimes we want it in our general form. So let's take this and put it in general form, and then we'll look at advantages to each one of these. So let's write this polynomial in our general form, and then we'll see when we want each one of these forms. So to put this into our general form, we need to multiply it out. So this is really like 5 minus 2x, and then 3x minus 2 squared says 3x minus 2 times 3x minus 2. And we're going to multiply this polynomial out. So we need to first distribute 5, and then we're going to distribute -2x. And so to begin, the result would be 15x minus 10 minus 6x squared plus 4x. And then we still need to multiply that all by 3x minus 2. Let's just simplify that some more. We can take this and combine 15x and 4x. We've got 19x minus 10 minus 6x squared. And we still need to multiply by 3x minus 2. So I'm going to actually distribute the other way now. Distributing in 3x and then -2. All right, and if we did that, we'd get f of x equals, distributing 3x in first, we'd get 57x squared minus 30x minus 18x cubed. And then distributing in -2, we would get -38x plus 20 plus a 12x squared. Lastly, we just want to write this as simplified as possible, and my suggestion is to write the largest degree first. So -18x cubed would come first. Then I'm going to combine my squared terms. 57x squared and 12x squared would be 69x squared. I combine my x terms, -30x and -38x makes -68x. And then lastly, I just have the constant term of 20. So in this form, once I have it looking this way, I see I've got 3 would be the degree, -18 would be the leading coefficient, And then positive 20 would be the constant term. Those features are easy to identify from standard form. The zeros, which is places where the function will output 0, are easier to identify in the factored form. Zeros occur where the function equals 0. So if for any of my factors I had a value of 0, the function would equal 0. So what we're going to do is take each factor, so 5 minus 2x, and set that equal to 0. And then since 3x minus 2 happens twice, we could set that equal to 0. And if I solved each one of these, by subtracting 5 and dividing by negative 2, I'd actually get x equals positive 5 over 2. And here if I added 2 and divided by 3, I'd get 2 over 3. So 5 over 2 and 2 over 3 are my zeros. One additional feature that we want to talk about that will be important in our next video is the idea that 3x minus 2 occurs twice. We would say that that is multiplicity of 2. Also notice that I could have determined the degree of this polynomial by adding the exponents. 1 plus 2 is 3. So from factored form, we can still come up with the degree. And remember to hang on to that idea of multiplicity for our next video.